The comprehensive overview of ocean acidification's effects on marine life politica. Increased carbon dioxide emissions are the root cause of ocean acidification, which is an ongoing process worldwide. This process occurs when carbon dioxide dissolves in seawater and reacts with water molecules to form carbonic acid. As a result, the concentration of carbonic acid increases, leading to a decrease in seawater pH, making it more acidic. This process has significant impacts on marine life, from the smallest plankton to the largest mammals. In this venture, we will explore the effects of ocean acidification on marine life and how it may impact the future of our oceans. The science behind ocean acidification. The oceans play a crucial role in regulating the Earth's climate by absorbing excess carbon dioxide from the atmosphere. However, human activities such as burning fossil fuels are producing more carbon dioxide, leading to the oceans becoming more acidic. This increase in acidity has significant implications for marine life and the entire marine ecosystem. The pH scale ranges from 0 to 14, with a pH of 7 being neutral. Seawater is slightly alkaline, with a pH of around 8.2. However, since the Industrial Revolution, the ocean's pH has decreased by around 0.1 units. This may not seem like a lot, but it represents a 30% increase in acidity. If we continue to emit carbon dioxide at the current rate, the ocean's pH could decline by another 0.3 to 0.4 units by the end of the century. This would represent a 100% increase in acidity compared to pre-industrial levels. Impacts of ocean acidification on coral reefs. Description: reduced calcification rates. As ocean acidification reduces the availability of carbonate ions, coral reefs struggle to maintain their calcified structures, leading to slower growth rates. Increased dissolution of existing structures. The more acidic seawater may dissolve the calcium carbonate structures of coral reefs, making them more vulnerable to storms and erosion. Reduced reproduction and recruitment. Ocean acidification can impact the reproductive success of coral reefs, which can lead to reduced recruitment and ultimately lower coral abundance. Shifts in species composition and diversity. Some species of coral may be more vulnerable to ocean acidification than others, leading to shifts in the diversity and composition of coral reef ecosystems. Impacts on marine life. Ocean acidification affects marine life in several ways. For example, it can reduce the availability of calcium carbonate, which is an essential building block for many marine organisms, including coral reefs, shellfish, and plankton. As the ocean becomes more acidic, calcium carbonate becomes less available, making it harder for these organisms to build their shells and structures. This can result in weaker shells or even the inability to build them at all, leading to reduced growth rates and increased mortality. Another impact of ocean acidification is that it can influence the behavior of marine organisms. For example, some fish may become more attracted to the scent of predators, making them more vulnerable to predation. Additionally, some species may have trouble detecting sounds, which can impair communication and navigation. Ocean acidification can also impact the food web. Phytoplankton, which are tiny algae that form the base of the marine food chain, rely on calcium carbonate to build their shells. As the availability of calcium carbonate decreases, so does the abundance of phytoplankton. This can have cascading effects throughout the food web, leading to reduced populations of fish, marine mammals, and other organisms that rely on phytoplankton as a food source. Potential solutions. Reducing carbon dioxide emissions is the most effective way to address ocean acidification. However, this is a complex issue that requires a global effort to address. Some potential solutions include switching to renewable energy sources, improving energy efficiency, and increasing carbon capture and storage. Additionally, some scientists are exploring ways to enhance the ability of the ocean to absorb carbon dioxide, such as fertilizing the ocean with iron to stimulate the growth of phytoplankton. Another potential solution is to develop species more resilient to ocean acidification. Scientists are exploring ways to breed shellfish and other organisms that can tolerate more acidic conditions. Additionally, some researchers are investigating the use of genetic modification to enhance the ability of marine organisms to cope with ocean acidification. Case study: the impact of ocean acidification on oyster farms. Marine biologists have had opportunities to study the impact of ocean acidification on oyster farms in the Pacific Northwest. In recent years, the pH levels in the surrounding waters have decreased due to increased carbon dioxide absorption. This decrease in pH levels has had a significant impact on the oyster larvae and their ability to grow and develop. During a recent study, we found that oyster larvae exposed to acidic waters had a harder time forming their protective shells, leaving them vulnerable to predators and environmental stressors. As a result, the oyster larva had a higher mortality rate, and the overall production of oysters decreased. This decrease in oyster production not only impacts oyster farmers but also the local economy and the food supply chain. Oysters are a significant source of income for many small businesses and provide a source of sustainable seafood for consumers. This case study illustrates the real-life impact of ocean acidification on marine life and the broader community. It highlights the need for further research and action to mitigate the effects of ocean acidification and protect our marine ecosystems. Conclusion: ocean acidification is a significant threat to marine life and the entire marine ecosystem. It is essential to understand the science behind ocean acidification and its impacts on marine life to develop effective solutions. Reducing carbon dioxide emissions is the most effective way to address this issue, but it requires a global effort to achieve it. In addition to reducing emissions, developing more resilient species and exploring other innovative solutions may also help mitigate the impacts of ocean acidification. It is crucial to act now to protect our oceans and the many species that call them home. Insider tips. It's important to understand the chemistry behind ocean acidification to fully grasp its impacts. The impacts of ocean acidification are not limited to marine life. They can also impact humans, who rely on the ocean for food and livelihoods. It's crucial to act now to reduce carbon dioxide emissions and protect our oceans and marine life. What is ocean acidification, and how is it caused? The absorption of carbon dioxide emissions from human activities is what causes ocean acidification. Who is a victim of ocean acidification? The marine ecosystems and their habitats, along with the economies that are dependent on seafood and other related aquatic organisms. How does ocean acidification impact marine life? It can disrupt the growth and development of marine organisms, leading to population declines. What can be done to mitigate ocean acidification? Reducing carbon emissions and implementing sustainable fishing practices. How serious is the threat of ocean acidification? It is a significant threat to the health and sustainability of marine ecosystems. What are some objections to addressing ocean acidification? Some may argue that it is not a pressing issue or that it is too expensive to address. However, the long-term consequences are dire.